Professor of Earthquake Engineering and Masonry Structures, member of the Slovenia Academy of Sciences and Arts, honorary member of the International Association of Earthquake Engineering, researcher for almost 60 years, former director of the Slovenian National Building and Civil Engineering Institute, internationally renowned expert, visiting professor in many countries, including Italy, Japan, Mexico, Germany, India, and probably many others. Invited keynote speaker at many conferences, author of seminal research papers and several books, including famous classic book on earthquake-resistant design of masonry structures, masonry buildings. Well, Miha, I'm Svetlana Berzev, founding president of the Serbian Association of Earthquake Engineering, and it's a pleasure to be here today in Ljubljana, Slovenia, with you, Miha, in your office. And as you know, this interview is a part of our initiative of the Serbian Association of Earthquake Engineering, and the initiative is called Great Minds of Earthquake Engineering. And you are the first great mind we are interviewing for this purpose. And we would like to chat with you about your life and career and learn about from you. I had the privilege to know you have had the privilege to know you for almost more than 30 years, I think now. And it's always been a pleasure to talk to you, to meet you, and to collaborate when we had opportunity. So, well, we'll start with your early days, and hope all the questions are not inconvenient to you. But first question is, I think, natural one. Can you recall a moment from your childhood that sparked your interest in engineering and or problem solving, something along those lines?
Well, before I answer your first question, it's my pleasure to be chosen as the first among the great minds of engineering. Maybe you are exaggerating in this regard too much. I'm just a usual researcher. Maybe, I don't know, I was lucky to be, during my career, let's say, as people say so, at least, the right man in the right moment. And everything was the consequence of this very simple situation. Well, my family, mother and father, came from different provinces. My mother was the daughter of a very famous doctor in Ljubljana, whereas my father was coming from the very simple family in Gorenska, who was the son of a blacksmith. And they met. They met when they both graduated in how to say, Slovenian language studies as a young professors in Maribor, just before the Second World War. And it was just because of that war, because Germany occupied Maribor, they moved back to Ljubljana, that I was not born in Maribor, so I was born in Ljubljana. My childhood was very normal, very happy, I must say. Things are very much different as they are today. Also, the place where we were living, there was the, how to say, rock house. The only one in this part of the region, there was the farmland, still meadows, cows, things like that. And today you will not recognize this sort of. So as a children we have plenty of air, plenty of freedom. And okay, we didn't feel as they many times are not enter into the politics. They were very happy times for young people, most of us, let's say. So then school, well, primary school, at the end, it turned out that I was the best pupil of that. And as a reward, I got, how to say, saying book in the bank, about 1,000 Yugoslav dinars at that time. It was a golden book and a tour with the bus across Slovenia. And that was the first time when I met Peter Pfeiffer, the other, maybe even greater mind of earthquake engineering in this country. So it's interesting to say, when I mentioned him, then from then on, he doesn't remember that we met in this bus. We sat like we are sitting next to another. And we were schoolmates from the first, at that time we had elementary school, which was 4 years, and then there was the gymnasium, okay, which was 8 years. And from the first class, let's say of today, is the fifth grade of the elementary school, we were schoolmates. Up until the university, graduated, he was before me a little bit. Was one of the first, I was not first, I will come later to that, because why it was so. And still today, we made, I would say, successful careers in earthquake engineering. So the hobbies at that time was quite different. He was playing chess, he was very good at that. I was playing piano. I was a jazz pianist when, at the end of the elementary school. Pretty good. I even participated at the 3rd Yugoslav Jazz Festival at Bled. So, is it enough for the beginning?
Okay, yeah, it's a great story, yeah. A great story you told about.
It's just an ordinary story.
Well, it's special. Every story is special, and yours joined with Peter Pfeiffer's is particularly
yes, I would like to mention
special
before,
in the first part, yes.
Did not influence my career, but it happened.
It happened, so that's circumstances, life circumstances. And were there any role models for you that influenced from your family, friends, relatives, that influenced your choice to go for engineering as a child, like in your early
Well,
years?
if you mention engineering, maybe yes. Because my wish when I was teenager, was ships, sea. You know, and I was planning to study naval architecture, at least. Very seriously, I had a cousin who was of the same opinion. Everything in that period of time was about sea, ships, World War II battles, ship battles. There was a series of books by some Croatian, I don't know, it's a naval officer. Hell on Pacific, on the Battle for Atlantic, something like that. Very interesting book. I just knew that the contents of this book by heart, so no problem. And even when we were younger, we played with little ships, which we made by ourselves and sank. All this famous battle, Trafalgar. In history, I will not speak about that. We are at earthquake engineering. And then when time came to go to the faculty, there was no faculty of naval engineering, even mechanical engineering for ships, shipbuilding and something. There was in Zagreb. All right, at that time, I already had a girlfriend. My wife. So we know each other maybe more than 60 years. It's a long time to stay together. But still, we come along. So no problems. We love each other. And it was number one to leave my girlfriend. Maybe I'll lose her or things like that. And then the other thing was about piano player. I didn't really want to make a career in music because I knew that it's a very hard job, so it's just hobby. And then what to enter, which faculty to enter? Naval engineering, civil engineering, well, it's the same thing. It's something you build buildings or build ships. So I entered civil engineering. Well, this is nothing very special, very specific, just we'll see. So
that was how it was, civil engineering. Interesting, yeah, how life takes you.
Which led me to this famous career.
Yeah. That's great. We'll hear more about the career. And during your studies or earlier, do you recall when was the first time you heard about earthquakes and how did that influence and did it influence your church?
It was when I entered the third year, the Skopje earthquake of 1963 occurred. And then when I got, also by chance, employed at this institute, at that time it was Institute for Testing and Research in Materials and Structures, ZRMK, called in Slovenia, also known all over the former homeland. Well, I used to do some research, and the first thing I was part of a research team when in Yugoslavia what's say, not smooth, but this reinforcement. What's the name?
Deformed bars.
Deformed
steels.
Introduced, and we did very comprehensive research on dynamic characteristics of this reinforcement. This was a research granted by the federal funds for research, which was quite important, not Slovenian, but federal funds.
From Yugoslavia.
There are two possibilities at that time to get money for research. This was my first collaboration with, I was not in charge, of course. I did then experiments and dynamic testing. Nothing.
You did all the work, but somebody else got the credit.
All right. And then there was in '69, there was the Banja Luka earthquake. Also, well, I must say that after Skopje earthquake, this institute, or former name, was responsible for repair so on of masonry structures. We had
in Skopje,
in Skopje, yes, we had some experience before that. Oh, we have been looking. What's this? Very interesting to tell. I was not part of this research, but at that time, as I said, no computers, not very well analog equations to solve the problems of distribution of shear stresses and tensile stressing in masonry wall after Skopje earthquake was point of interest. We all saw this, not me, but my colleagues, this shear cracks and what's the reason? What's the cause of these shear cracks? And we studied, my colleagues, first on this, this is epoxy glass on the, what's the name? Photoelasticity principles. I had a older colleague who was very, actually he was, his diploma was geodesy. But he switched between these to civil engineering and some mathematics and some. He was one of the beginners in this institute with model testing. And at that time, in the elastic region, that was the only way, was this plexiglass, so you could see all these ISO lines and then analyze and see the distribution of
so they were used in after the
so they confirmed the theory of my former director, my mentor, Victor Turenšek, which is still Turenšek equation for shear distribution.
Well known.
For
so that was the tool used after. Very interesting. Very interesting. Yeah, in fact, that was, maybe can you tell us more about the mentors or mentor whom you had early on in your career once you started working?
Early career was, of course, Professor Turenšek. He was a very, very clever guy. He was a type of, actually, of the original brand of engineers. So he was really an engineer, but at the same time also a researcher and scientist. He was very fond of mathematics, he was very good at mathematics. When he was 70, he learned computer programming.
At 70?
At 70.
Wow.
Oh, yeah. Or at 40 and anything like that. So he understood very well. He covered all the spectrum of problems which have been studied at this institute, from geotechnical aspects to
and he was the director at
He was the director, the founder and director of this institute. Really, he taught me engineering, thinking, reasoning.
For how many years did you work together with him?
Well, not, quite some. He passed away in 81, so...
And was active until...
he was active at the end. We went, I remember, just 1 month or 2 months before, we went together to Italy to some conference in Rome, not work conference, but this was another step in my career, this Friuli. After that, maybe I'll tell you some more about this. It's interesting.
Okay, so you worked with him for more than 10, 15 years, something
like
that.
More
than 10 years.
My mentor. So I, once at some celebration, I had this little speech, and I don't know how it came to my mind. Maybe interesting. You can cut this off if you like. That I had actually 3 fathers. One was my real one, and the other was Professor Turenšek. He taught me research and everything, how to, directed me into, I think, in the right direction. Not too much detail, but all over to get the wider picture of all phenomena, all problems. And the third one was, this is another step in my career also, a Japanese Professor Minoru Wakabayashi. He was my professor in Skopje at that time, maybe later. So these were my main mentors, let's say.
So thank you, and maybe I believe it's also a relatively early part of your career, talking about this defining moment, which or event or circumstances that set you really to this path of earthquake engineering.
Defining moments, I would say, but it was not really my decision. This was the flow of the events. Okay.
Draw of luck or whatever.
It was first the Banja Luka earthquake.
1969.
1969. We spent some time there, also in the field of masonry, building. Then we
So you were surveying the buildings.
Surveying the building after the earthquake, and then were engaged into design of strengthening and repair. And then there also our collaboration with the Skopje Institute came.
And that was they were already founded for those who don't know, 1964 or something, 65.
They were,
after the Skopje.
Something like that.
They were already established.
So we did some testing. We took, I don't know how many, quite so many. It was a truck transporting all the specimens which we took from the building, just normal size walls. We tested them there, and in Skopje they used this data and calculated, I don't know what exactly. Oh, at that time they used method which Professor Boško Petrović. So at that time I got familiar with Boško. Okay, he was a very nice guy. He was your
my mentor, my father. He also said that he has two daughters, and both of them had the same name because his real daughter had the same name as the same. That's right. So we have more than one father.
Then in 73 or 70, I think 73, we had a minor earthquake in Slovenia. In the region near to Croatia, Kozjansko. And this region was very poor. Stone masonry houses and nothing really as an event, not to mention spectacular, but many of these houses were severely damaged, and decision was made to repair them. How to repair them? At that time, I was involved in damage assessment and things like that, but not leading any specific project, just being part of that. And we got money we introduced two methods to say how to repair this kind of building. One was how to strengthen the walls with injections, grouting, cement grouting. That time we used cement. We didn't know that the consequences of using just cement or not. As regards strength was okay, but humidity and things like that, physics,
compatibility
of materials are not so. Then we improved and we added some hydrophobic components, materials to improve this situation. And the more important issue was tying the walls with this. So to make the structure of the building work as a box. So united together we are strong. If we are separated, no way to resist earthquake forces. Just if it happens to be implemented, I like people, so that's the same. So if you implement the tying, you have done 50% of the strengthening for this type of buildings. And then next step was the Friuli earthquake in 76. Well, in between, I already finished my master's in Skopje Institute. In Skopje, they had a very nice program of education sponsored by UNESCO. It lasted, I think, 10 years. So it's a 10 years program, 2 years courses, just 1 year. I think it was 1 year course. I missed this.
1 year program.
1 year
for the
condensed
same
program.
Like a master degree.
Master complete. Maybe, I don't know. I didn't ask. But most of my generation colleagues, famous in earthquake engineering in former Yugoslavia, used this opportunity and finished masters and got master's degree in this 1 year
in
course.
1 year,
I was kind of, I will not speak about the reason, but anyway, it ended that I attended the last opportunity, so the last 2 years when the program was over, and I think that additional funds or funds were left, so they called many experts, professors from abroad. So we spoke yesterday. I think I passed more than 30 exams in this course and met most really great minds in earthquake engineering.
Can you mention some of them?
Well, this was Wakabayashi, and they were from Japan, and there were some Kyohei Baba and Professor Izumi from Japan, and no, Professor Muta was not coming there. And then, you know, Leon Finn from Canada, geotechnics. There were Professor Arya, also very good friends of ours. You name them.
Did you have Professors Polly and...
No, Polly was not yet known at that time. So it was, it came later. Okay. I don't know, maybe Professor Klaff also was there. Not
you mentioned Professor Skinner, I think.
Skinner, yes. Professor, this was my...
New Zealand, yes.
I never met him in Skopje, I missed his course, but I passed the exam. So it was, very nice. So it's still, I'm using knowledge which I acquired at that time. It's really
so that was a defining, I would say, stage of
I think that nowadays, I think that's a Rose School in Pavia, which led by Michele Calvi. It's some sort of similar, but I'm almost sure that the level of the education in Skopje and those
was outstanding, and the depth also of education,
this was
given the 30 courses.
Professor for it was reinforced concrete. I think he stayed there for 2 years almost. He was on sabbatical with his family, Larry Selna. Los Angeles University. So it was okay. And then, if I may go on with my story, or you have some other...
Well, that was about Skopje.
And then
we have
after
next,
that, just immediately after that, it was this Friuli earthquake. And this is what our institute...
So when did you complete the studies in Skopje?
Yeah, I just completed.
So it was 1976? Or?
No, 76, yes. Well, I didn't actually already... everything was gathered together. Material calculations were done there. In Skopje, because in Ljubljana at that time we didn't have any computer here in the institute, so what has to be calculated was...
And they had in Skopje.
They had and at that time I was missing a plotter here, so all these plots in the dynamic response and
were done in Skopje.
Now here by hand. So it was a little bit crazy story. Similar handwork like
your
my
undergraduate.
My master's is also like torturing small animals. Making joy. Okay, and at that time, you know that you remember probably, or maybe not, you're too young for that. This was a series of 3 earthquakes. One was in May, and there were 2. They consider them separate events in September.
That's in Friuli.
In Friuli, and also affected the Socha River Valley in Slovenia. So
it was close to relatively close. How far away is, for example, that area from Slovenia?
Well, the epicenter is maybe 15 kilometers
very
from
close,
very close.
The border.
So it affected also the region where is very strong Slovenian minority living. And for that reason, the Slovenian government at that time decided to help them, to assist them. And our institute was in charge to teach them how to strengthen this building. For that purpose, they formed a small firm, some company of masons, which most of them work in Switzerland, came back to Italy, home, and were instructed by our staff how to do this, how to inject, how to make this, everything. What this is specific works, you have to have some experience in doing that. And just by chance, we had the 3 pilot sites, and on one, which is very near to very epicenter, maybe 5 kilometers from there. It was completed, so strengthening with this grouting and tying. And the building, which also, this is important to mention, we decided to strengthen the building which Italian authorities decided to demolish, just to show them that it can be done.
That is called today Build Back Better. So you did that.
And then this building, no damage. All around collapsed, which were already...
But that was done before the earthquake. You said no damage. Was it
Well, no. They were damaged severely after the May event.
That's what I thought,
And to be demolished, was the decision. We said, no, we will show you that it not knowing that it will be some other events very soon. And in September, well, this was also still a construction site, but the main structure
was strengthened already, no damage.
So no additional damage. And this building became a star on the TV, and so we became
also stars.
And the point was at that time, I don't remember why it was so, well, in Italy, although they had very strong earthquake, Messina earthquake, and some other on the south, there were some names like Cali, Cancani. No one knew that this is northern part. It was not a seismic region. And step by step, Italy now is completed. Actually, well, the map, seismic map is, well, more or less all Italy is seismic zone. And the Friuli earthquake really triggered the earthquake engineering in Italy. Before that, there were a few names, but they didn't, I don't know what was behind. I was too young to, maybe something in between the Italian regions. Nobody really came to assist people in Udine, in this Friuli, Venezia Giulia region, which is an autonomous region. So they came to us whether we will be ready to Chamber of Engineers of Udine, whether we will be able to have some seminars, to teach the people and so on and so forth. And we organized two events. One was in...
Was it in Italian or in...
Well, it was in English.
English,
okay. I didn't know, although I learned
Italian.
Latin while being in school, but we went to shopping, so I understood some Italian. After that, there were, maybe we also had to repeat the one in Udine, and the other one was in Pordenone. So two locations, full
rooms,
full space available. Everybody came to listen. It was a 3-day seminar. So I was at that time just graduating, master. I was just speaking about dynamic of structures, introduction to earthquake engineering, things like that, which I consider very important. And the other colleagues thoughts about how to repair, how to strengthen, things like that, technical issues, and so. And then I was the problem was, yes, the lectures were held more or less in Slovenian, not just because to emphasize that Slovenians are living there, minority, but it has really had, this collaboration had a very, very strong influence on recognition of Slovenian minority. So from political point of view, the decision of government, Slovenian government, to send us there was extremely important. Still they are very much aware that we are the ones who help them to show that Slovenians are not just not all, but some of Italians still today. You know, Yugoslavia. Pfeiffer once told me that when he sent a paper to some journal, one of the reviewers wrote, "Who is this guy from this? Where does he come from?" Huh? Something very insulting, for he still remembers this. He suspects who was the guy who wrote this, but really, I don't know. Still, maybe today it's better, but at that time we were very much underrated.
So you had a defining moment, first master's degree studies in Skopje, and then Friuli earthquake of 1976, and all the great activities. And what happened next?
Well, first I would like just to mention that after the Friuli earthquake, I was invited, maybe because I was the only one from the group, from the institute, who spoke English, to join by a decree of the president of the region Friuli Venezia Giulia. I still keep this document, invitation letter or decree. It was a decree that Miha Tomaževič became member of the Gruppo Interdisciplinare Centrale. This was a group which managed all the activities after the earthquake. So, all bureaucracy, codes or recommendations and things like that, which were then published in the documents, some sort of codes, local codes in the region. And in this code for structural design, let's say repair and strengthening, we included all our experiences. At that time, after the earthquake, or even a little bit before, I already was kind of familiar with computer programming, and we had a method. Actually, it was the idea of Professor Turzek to evaluate the earthquake resistance on the basis of some iterative study, some procedure based on some parameters. But then, when I also got used to programming, it came to my mind, why not simulate some testing? You push the building and calculate the resistance which corresponds to the certain displacement, and you got this, we call it hysteresis envelope of all the walls. Like at that time, nobody knew about pushover method. It was a pushover method, actually. And I had ready the program, already tested it, and I suggested, because it's really very simple, it's not finite elements and something which you superpose this hysteresis envelope as a bilinear on some basis, of course, not just imagination. There's some argument why these curves are as they are, and we introduced this into this Italian, and the name of this program was POR, P-O-R, which are the first three letters of Porušna metoda. Porušna metoda. We call it Porušna metoda, okay, because we studied, we tried to evaluate the resistance
of the structural elements.
When this structure will fail, collapse, porušito, collapse. And it came to Italian use as a method POR, il metodo POR. And for many years, nobody knew actually. This was with the source actually program.
Source code,
it was published in this document, code. It was, official name was Documento Tecnico numero 2. Technical document number 2, because it was second on the order of all this bunch of documents needed for reconstruction of the area. And it was so simple that it could be used, applied on these calculators, simple calculators at that time. So engineers who worked at that, when they discussed between them, my calculator is capable to manage 50 walls, my 20, but these ordinary houses are not very high number of structural walls to be. So this was my, in a way, my most important achievement.
Because of the use of
because of the use of simplicity of the method, which on the other hand turned to be very accurate. We always, when we tested some model or some structural assemblage, correlated the calculate, was kind of blind test or they have some competitions nowadays to calculate what will be the outcome of the test, who will come closest to the actual test results. And we found that it's more or less, as I always say, it's not exact. Nothing is exact in earthquake engineering. It's just about ranges of values. Approximation. So you get the idea whether your structure will behave adequately or it's subject to collapse. All right. This is my personal point of view. So maybe I'm not. I will come to this book later. All right, and so this was very widely accepted, and for many years Italian used it, and finally, actually, what they have today in Pavia there, or in Genoa, also these tre muri. This is basically. This I would like to have, but I didn't know how to make it. But the idea, you just couple the hysteresis envelopes. The model is very simple, I think. And here, my colleagues, which I hoped that will be able to do this simple thing, said this is impossible, this is numerically not stable, this is I don't know what and how. If you do this in a very simplistic way, by hand, it works. If you do in the more accurate, more sophisticated, scientific, let's say, a combination of solid elements and springs and whatever, which simulate the actual behavior, then it doesn't work. How come? No? But I was too old to get closer.
To argue, yeah. Okay.
So that's it. And then, after this Friuli experience, which lasted for about 5 years or something, it was Japan. I was, I don't know, I don't remember actually how I got a grant from Japan International Cooperation Agency. This is maybe on the basis between some agreement between Japan and Yugoslavia. It's for developing countries, some grant, which was for 2 years, but 2 years, it was a bit too much from away from home, so I shortened it to 1 year, and Professor Wakabayashi helped me to come through with this proposal, and even 1 year was too much, and we stayed to half a year, and this was the limit, so I have to go there for a while. And this was, again, one of the very important experiences. Actually, I was not doing much in regarding research. I was staying in Kyoto in the Disaster Prevention Research Institute. So Kyoto was a very nice place, and the people from there, they liked me, okay. Wherever they went in that time, from Sapporo in the south to Kyushu in the north, I visited maybe all important places in Japan. This is very, very nice. And at the end, they also found some, I don't know, some company to do a little research in masonry. So we tested small models on the shaking table. There is some anecdotes of Japanese thinking and Yugoslav thinking. They told at that time, you Yugoslavs are very smart people. And I will tell you why. There were small walls like 60 centimeters, I guess, very thin models. And of course the compressive stress was applied by means of, I don't know, that much, 2 meters by 2 meters steel plates. And there was, in order to prevent the swaying and things like that, there were 4 columns and very tiny, like fingernail joints. And when I saw this, I asked them, is this, where did you get this? Oh, in a shop. Is this from some spaceship material? No, there's no force, it's just that. I said, well, if it will work, good. But it turned out that as soon as the shaking table starts moving, boom, boom, everything was on the ground. Naturally, you cannot prevent that there will be some unexpected motion. It was. So then they got like a fist joints, so and it works. So this is just like, I don't know.
Story about
like in Kobe earthquake. They had scenario number 1, it didn't work. Number 2, it didn't work. Number 3, it didn't work. They were lost. What to do? No. So it's our way is different. We improvise.
Of thinking, of working.
We don't know. We don't have facilities. We don't have, and we improvise. We find, and the result is
good. At the end,
it's good. And this is what I learned from Professor Tomaževič. You can do this if you want. Just take whatever you have and use it in a proper way. The result will be just the same as you have tested this by some fancy facility. This I miss today. Today we have everything in our lab. I'm just jumping again from topic to topic. At that time, when I was a beginner in this, we had analog system, there were tape recorders, 6 channels, and we had also another 6 channels on a VisiCorder. This was a photographic, paper, and it was Philips instrument, and you have to fix this with some, I don't know, like a photographic paper, and this was analog. If you calculate, you need digital data, no digital data. No? This was the point. So you have to think very well before the test where to put the transducers, whether strain gauges or displacement meters or whatever, accelerometers, to get the data you need. Now you have a billion
abundance
of data, and you don't know which point to pick. Because the analysis of all this data all together is a time-consuming procedure, and nothing. At the end, you just get nice pictures, as I say, without really using the data, the strength of the data.
The most important data that you have,
That's the problem.
Okay, so that is now this takes us to maybe your research and the topics that are the most important in your opinion, and how you...
When I came back to Japan, I realized that I'm already famous. In Italy, I was Professor Tomaževič, and did nothing. And then I decided, okay, guys, now it's time to start working. And I was lucky to have another guy in my group. This was Still, I'm very grateful to him. That's why I'm mentioning. He's the only one who you mentioned. He for 3 years we really worked very hard here in the lab. Did all things together. From we were masons, we were technicians to control the testing facilities. We were programmers for data acquisition. We were allowed to use the separate disk in our computer. At that time we have computers, so we were allowed to remove in the afternoon, put this during night, and so on and so forth. So without him, maybe I will not be as I am. And the point of interest at that time was first reinforced masonry. This is the thing, still today it's unsolved problem. I don't know how there are many systems of reinforced masonry, but all the equations which are given in the codes are unique for whether you have the reinforced grounded masonry, you have this, all the systems which exist. But the differences in behavior are tremendous. So in most cases, you just place the reinforcement, the steel, you burn the steel, no effect of this. There are so many parameters which influence the activation. It's not like, in Yugoslav code former, which from 82, the one, which was very good, very modern code.
But those clay units would be used more in the context of confined masonry, which is your star topic.
That's another issue which makes me, if I would be still active, I will I was telling already, I will ask by my successors which topics would you still investigate? And one is just confined masonry. You remember that meeting in Lima,
2009.
I mentioned that maybe we are going too far with reinforced concrete, which is true, I think. And the last test which we have, this full-scale test, which I was in a few years ago, we tested again a system proposed by Wienerberger or some other producer, and we were confined masonry according to your code. And what was the final result? The building did not collapse because of the columns. No masonry walls, all went, but
disintegrated. Yeah.
What is that? Is this, you know this, masonry first, columns later, columns first, or concrete first, masonry later. This is the basic difference between the reinforced concrete masonry infield structures and confined masonry structures.
There's a thin line sometimes.
Yeah, we are coming close to the, and what bothers me most, by year codes, we are not allowed to take into account the contribution of confinement, which is significant. If you accept the year codes rules at each window border, and you have,
Confinement.
you have too much confinement. You have, as was the result of this. I would like to know where is this limit, okay, red line between confined masonry and
reinforced concrete frames with infills.
Yes, this is the one, and well, there will be still some other. What bothers me also is this famous structural behavior factor. I don't know why don't we call it just simply force reduction factor as in Americans do, but much more understandable. So physically, and why you reduce forces? This is the problem.
So, besides these topics, you have made, of course, your research on confined masonry, on unreinforced masonry structures is very well known, and studies, shake table studies, all kinds of experiments. But one of the, I think, things you are most well known for, it happens to be so, is your famous book. Here it is, Miha and the book. So, how did it happen? How did you write the book?
Well, this book actually is the result of confidence of the editor of this series in me.
And who was the editor?
I hope I didn't disappoint him. Well, Amar Elnashai at the time was in Imperial College, and his idea was to publish a series of books. So it's here, innovation in, I don't know, engineering or something. Innovation in structures and construction, okay. And his plan was to find colleagues who would be ready to write books on, let's say, like myself, in masonry, construction, reinforced concrete, steel, wood, this
all major materials.
And well, he asked me, I don't know what was the reason, we discussed this, and he said, yes, because it was you. Okay, this was he liked me. All right, we were good friends at the time, still are. We recently met twice for some time, so, the last time in Split, 1 year before in Zagreb. And, well, I accepted. I had some experience. I coordinated, I was not coordinated, but what was this? This is the first thing, my first attempt to write something consultant. I was consultant.
How was that written? That was before the book, yeah?
This was before. So the idea was, this was part of the Balkan project named Building Construction Under Seismic Conditions in the Balkan region.
So it was after the Montenegro earthquake, yeah?
Yeah.
After it was, I think it was 1980s.
All right, yes. What is the year of publication? I don't know.
I think it happened in
1884, it was after Montenegro earthquake. And, already had something tried to write in some wider form, and this was the idea of this. There was a series of manuals published within this framework of this project, and my duty was to collect and edit a bunch of materials which I will be getting from colleagues working in the group. But it turned out that, how to work in these committees to write some document is not so easy, besides your work, not paid and things like that. Yeah. So I got almost nothing, just some examples of case studies, which was relatively easier to prepare to be included in this publication. So I decided to write my contribution, collect our experience, and this is the beginning. And then it was, I think, I was also teaching on the master's level at our university, masonry design, masonry resistant design, and even at that time, maybe it was already in the beginning of 80s, and at the University of Trento in Italy, I held my first course as a visiting professor, and for them I prepared the English translation of the textbook which I wrote for Ljubljana in Slovenian, and then. There was, I'm very proud to be part of this group.
Lido group,
Zemljotresno inženjerstvo. This is the swan song of Yugoslav earthquake engineering. This is not my copy, so in my copy I still keep the photos of all authors. It was already published when Yugoslavia fell apart. It happened in Bled, actually. And the lady who was important, who was in charge of this, I don't remember, she is not listed here.
Građevinska knjiga, yeah?
Yeah.
That was a publishing house.
Maybe it was Milica Dođić, I'm not sure whether there I have her signature, so she introduced the book in Slovenia. This was, I think, a good book. Okay.
So it is in Serbo-Croatian.
Serbo-Croatian. I don't know which.
What language at that time?
It was the language at that time. Today it's okay. one has to be maybe
translated to Slovenian and translated to Croatian and to many languages. So that was the last book that was published in but this was published before. This was published in 1990, whereas this book was published in 1990.
I'm just speaking that I had some experience before being asked from Amr to write this book, so I said yes. All right, and then at that time I was director of the institute, and time flies like an arrow, so the deadline to submit the manuscript became closer and closer, and I wrote this book in a rather short time, maybe 3 months. All was done in my free time, not in the office. At home, at that time, it's quite what I liked it. I liked writing, and I had ideas what to present. First of all, I decided not to be a classical book, textbook, with examples, with equations, too many equations, but so I think it's written in the preface that what's behind of what we speak about Masons, all these experiments, and based on my personal experience doing pyramid, I think, well, I was successful, so that in a simple way, not scaring people with many equations, which wizardry of I don't know things, but tell them in a simple way which are the rules to be respected and how to handle even the numerical or calculation or whatever background or proof that what you have designed is okay, will not be just demolished when the strong expected perfect will
collapse.
To prevent collapse. So this is the basic idea. And I started writing this book from behind. So the last chapter is repair and strengthening structure. It was, I don't know, maybe I was just writing a paper on that and then said, okay, this will be the base of the text, and let's do it. And then I already had a contract to prepare a second edition a few years ago. But at that time, I have seen that the book was quite well accepted. And I was, first of all, you cannot write a book without connecting some results, some facts with the codes, which are
changed,
valid at the time you have written the book. And still, the original version of the error codes was enforced, so still today. But this was the excuse, this fact. And I was afraid. Say that I have nothing very much new to say, to add to this, what is here. Basically, it's true. So maybe different experiment, maybe a little bit more support of what I'm explaining here, but nothing really very new to say. So I decided, and I was old that already, so I'm not planning to. Well, now just I'm working on the paper which I presented last time in Split, and it's makes me no joy to write. It's a burden.
So I have a question. We have a question for you about based on all your experience, research career, and academic career. What is your message? What would you advise for young engineers? What advice would you give to young engineers at the beginning of their career? So, like researchers.
First of all, it's difficult to, give advice people people are very different. And my point is that you are or you are not. If you are in, it's very easy. You don't need to give advice. You can, if research is like art, it's your life. And so it's very words, big words, but it's
poetic,
so.
Sounds very poetic.
It is so. You are in and you are in. So you have time, you can find time for everything.
So let us go to the last question. And what do you see as the future of civil engineering? How it is going to develop and what are going to be the areas of major advancements, in your opinion?
Well, you are not asking the right person. I am a very traditional one.
Okay, in the traditional way, what is in the traditional world do you think would be?
Traditionally speaking, in terms of materials, terms of maybe not that technology, but use of innovative materials. And we don't know everything about traditional materials. But new materials, when I watch the concrete in, let's say, high buildings, of this river flowing to the concrete pump, I'm not quite sure what this concrete will be after 30, 50 years. No, maybe you know what I mean. And all this high-strength concrete, let's speak about concrete. No ductility, no nothing.
Yes.
This is the problem. Who knows that, all right, these are tall buildings, so the response to normal earthquake maybe will not be important. But how about this long period ground motion?
Which happened like Mexico City, a kind of situation, or that was...
medium, okay, but I remember, I have not experienced it, but this oil tanks in California, many years dishwashing processes. So there is some important thing which, but maybe I'm too, because, well, I would not live in a skyscraper like in Dubai. Think that things work. There was a fire a few years ago and nothing really happened, fortunately. But it's like this seismic isolation system, the active isolation system. I listened to some lecture some years ago. I've seen first how the system works in the conference in Tokyo, Kyoto. They showed a movie. There was a table in the boat, catamaran to table, and water vessel full of water, and it was on jacks riding the waves. Okay, it worked. All right, the water didn't splash over them, but the energy needed for activation all these devices on tall buildings is in the amount of the small city of 20,000 people. And in the case of earthquake, so you maybe usual thing is that electricity goes off, and you have to switch on the aggregates, so strong aggregates, and so it's a little bit.
So there are challenges with the advanced systems and with active systems.
It looks like nice in theory, but in practice, and it has to be well maintained. I think in our case, I don't know. I remember there was a school in Skopje.
Yeah, that was isolated, the Pestalozzi.
And
after the Skopje.
Actually, they several years ago they changed all the isolators, so it's maintenance is needed, and it's
replacement. Actually, its maintenance is in effect replacement.
I am more in favor of energy dissipators. This is another thing, but needs displacements.
Yeah, so it doesn't work with masonry that well.
This doesn't. Masonry may be
isolated.
only isolators.
Yeah, isolation is the solution for masonry.
It's not. All this. Some people propose.
But for concrete or steel structures, it would work well.
Buildings and structures. Because it's displacements you need. I remember when I think it was in Mexico. They tested some sort of steel dissipators. It was like steel plate, and 3 or 4 cycles the steel became red, so hot. Really, so it's a lot of energy is dissipated. So it's interesting. But I think the future. Not too much architectural experimenting. This is what I'm afraid. Architects are the. I had a lecture for architects, and I was looking for a definition what architecture is, and find a good definition. It's in Wikipedia, so you can find it. Architecture is something, a science which combines resistance, strength, and then the art and everything together. So architecture is the part of our, which is responsible for urban planning, also for design of buildings, to respect all these rules of proper construction. Without architects. Well, we engineers can calculate many things, but the earthquake does not ask what program you have used for calculation. It will just, without many questions, tell which building will resist the earthquake, which must. There are too many cases where we have seen buildings not designed for earthquake.
Performing well, and the others that did, but then,
That's.
This is the end of this interview. It was an amazing story. Thank you for your time. Thank you for your willingness to share your life and experience with us. And all these stories and messages are great. And thank you for your hospitality here in Ljubljana over the last 2 days. It was great to have a chance to spend time with you. So thank you.
Thank you, Svetlana and Marko. You will not be on but it's first of all, I don't know. I told you in the beginning, I'm not one of the great minds, so that's my concern. I really mean it. This is my humble experience to the work of earthquake engineering. Maybe I was helpful for somebody, but the high-tech world certainly will not be very happy with how I think about earthquake engineering.
That's okay. Life it would be very boring if everybody had the same opinion. That's what makes life interesting in our career.
Thank you very much for inviting me to participate in your project.
You're welcome. You're welcome. So thank you.
Okay.